Thanks for being here. I'm going to talk about Semantic Kernel, which is not very known SDK if you are not really dealing with LLM and orchestration. But before I talk about what this SDK does, I want to talk about why would you need this thing. So I am currently working with several partners within Netherlands who are exploring how to use large language model or small language models or an AI into their business process. And one of the things came up is, can I translate keeping my domain knowledge intact? So if you see the top English one, this is a very common error informational message if you're using an UI. So if you're inserting a record, it tells you this is an information. You also need to take into account that some archived records will be retrieved. Now, if you put this through any translation model available in Hugging Face or even Google Translate, how many of you are Dutch or know Dutch? So the parent will be translated to ouder. And that's a problem, because we cannot trust LLM to do that. We need to take into account our domain knowledge. So if we have something called parent, it should be something bovenliggende of something else which represents your UI, to be honest. So let me show you how things happen when you are using an LLM to do this. And I'm going to switch back and forth quite a lot today, so I hope everything goes all right. So I'm going to clear this chat. Where's my thing? So normally, when you are invoking an API which does the translation, you call the REST API with the text that you want to translate. So for example, just to reiterate that, I want to translate this sentence back to thing. And as expected, it always translates the parent records as other records. But what if those translation models has the ability to give some extra information along with the translation? So for example, if I say, take into account a list, I don't think you can see this properly, but take into account a list which has a key value pair of my domain-specific translation, and then use that knowledge on top of your translation capability and translate the same sentence back to me again. And now, it actually used the bovenliggende record. Now think of if you have to do 102,000 translation in a batch, and all those sentences comes in dynamically, and you have a domain knowledge list which is also dynamic, which can be in hundreds of thousands of records. So how to make that process of translating task to the LLM a bit dynamic, where you can pick and choose which text you want to translate, and pick and choose which key value pair you want to send to help the LLM to do the translation. And that's where these SDKs comes in, where you can use this properly to find, dynamically send variables to LLM to perform a task. So why we need orchestration? If you have a repeated tasks or prompts which you want to pass through or perform with LLM. If you want to reuse some of the prompts within your task list. If you want to manage the LLM config parameters, which I didn't show. Why? I don't know. I'm not sure how many of you know the list of parameters you can manage when you are invoking LLMs. 2 or 3. So the best one to talk about is the temperature, which varies between 0 and 1. And that basically controls the deterministic behavior of an LLM. So if it's in 0, it'll always give you the right answer. If it is 1, it'll always give you, not always, but mostly give you the different answers. So these parameters are also quite important when you're performing a task. So for example, if you're building a rules engine on top of LLM, you want it to be deterministic. If you are creating a paragraph or rewriting an email or summarizing a text, you want it to be a bit more creative or non-deterministic. So these parameters also quite important when you're orchestrating or invoking the LLM. And this also helps you if you have an SDK to manage it properly in a central location, to be honest, or task per task basis, to be honest. And other things that are important is if you have an existing application you want to integrate with, and it is written in Java, .NET, Python, or any other languages, it'll be easier for you to have a similar language SDK as well to operate on. And if you are connecting to an external knowledge base, vector or non-vector, doesn't really matter. Or if you're combining business logic with a task, to be example. So now that I give you a bit of a background on why this is needed, I'll jump into how Semantic Kernel is doing that. You guys know LangChain 4j or Haystack? Okay. So this is another SDK which is more comparable a bit. They have differences in their features and implementation and how you use it. But yeah, potato, potato. My name is Soham. I am a partner solution architect working at Microsoft Netherlands. I'm not a DevRel for Semantic Kernel. This is just my hobby and a bit of my work, to be honest. I do contribute on the documentation part of Semantic Kernel, and I love to talk about it. And I'm literally working with at least 10 startups in Netherlands who are actively working with LLM, LangChain, Semantic Kernel, or Haystack in that respect. But why this became a phenomenon and where does it all fits in? Maybe that's a better question to answer rather than how you do it, because how you can go to internet and find out how to implement something with some frameworks. But if you do understand the why, that's much more easier for you to understand what you want to use then. So a pioneer, Herbert Simmons, once told the machine learning consists of very hard steps. So you have a data warehouse or a set of data which you want to train, then create a model. Not only that, you need to separate those data into a training model, into inference, in a test, and blah, blah, blah. You do need experts for that. And I cannot do that. I don't have a data science background. But when LLM came in, it made it easier for everybody to pick and choose and write code from scratch. And within a few seconds or a few minutes, you have a running code base. Because LLM gives you an API. What you only need to do is give a task for it to perform. Sometimes you give some extra data so that it has contextual information. Like if you were in the Gemini presentation, there were function calling for different APIs to get the current data back. So it is dependent on the trained data. So you want to give it some context to get some information on the spot. And that data can be vectorized, that data can be normal text data, that data can be a tabular data. It depends on your use case, depends on your implementation, et cetera, et cetera. And at the end, you have a product, to be honest. And if we take a step back, this is pretty much comparable to calling an external API, which gives you a JSON data back. It's just that how you operate the API changes a bit. So to start with, you have an LLM API. That can be Gemini, that can be OpenAI, that can be Hugging Face, that can be your own local LLM. Doesn't really matter. It has an API, and it has a JSON standard to it. Then you create something called prompt. Like in the keynote, Liz mentioned the English going to be the best language. Actually, 3 years ago in PyCon, the father of Python code actually mentioned that the next 5 years is going to be English altogether. Then comes the prompt design, which sounds very trivial, but this is the most dangerous and complicated step in the whole process. And to be very honest, every client or customer I work with suffer or struggle with this. Because to tune a prompt is actually a harder task than writing sorting API in an algorithm in Java. And it also depends because every LLM has a limitation. And the limitation is not only your input, but also the output. And that is calculated by tokens. On a very basic terminology, tokens are a piece of word or a phrase or a few letters in a word. And every language model has a limitation. And you need to take into account that limitation also when you are creating an application on top of it. And then comes your data, that context that you extra provide. That's not always required, but sometimes you do want it to perform on a extra data. That just like the translation one I provided, that parent should be translated to bovenliggende. So that kind of a data you also want to provide when you want the LLM to do it on your way. So there are different ways to do this, like adding extra contextual variables, adding few short example or one short example, or giving a chain of actions for it to understand what are the steps I need to do to perform a particular task. Because at the very beginning, ChatGPT was super good with math. So we needed to provide how you solve a puzzle, for example. And then basically, you have your intelligent application. And semantic kernel sits in between, where you actually orchestrate how you enrich the context, how you add the prompts to the LLM, and how you manage both of the things together in a very deterministic way, to be honest. So let me show you some code before I move on. Is this visible at the back? Yeah? OK. Yeah, can be. How we initialize the kernel, I'll come to in a bit. I'm going to explain the core of how you define a kernel and how you add different stuffs to it. But let's say I have a function which gives me a kernel back. And everything in semantic kernel starts with a kernel. And the kernel is the one which orchestrates calling the LLM, invoking an API, calling your, I don't know, database, calling your vectorized database, calling your something else, or doing a business logic, or invoking a prompt. So kernel is where it starts with it. And it comes with a couple of services. And those services are, at the end, linked to a large language model. So the best and the most used Hello World example in LLM world is summarize something. So I'm also going to show that. So what I'm trying to do is I'm defining a prompt where the input is dynamic and the task is static. So the task gets summarized in less than 250 words, but the input is every time I invoke it, I pass that as a variable. So think of it as a function where it accepts one parameter and gives me back a string always. What I then define is the config parameters of that LLM. So when I'm invoking this task, how should LLM perform or be configured to perform this task? I'm not going to go in top P. Top P and temperature are actually quite related to each other, but there you control the config parameters. You also mention how much tokens you want to use. Because when you are creating a business application, if you know, LLMs are being cost by number of tokens processed. So when you're creating a business application, you want to have a control over how much tokens you are passing per request, so that you have a deterministic cost model behind your application as well. Because when you are using a database, you know how much storage and CPU you're going to use, so you have a cost model associated with that region where you're deploying it. If you're having an AKS cluster, you know how many nodes and what is the VM configuration I'm using. But with AI, that's not predefined. It can only tell you use this much of tokens so that you're going to pay this much of money. But if you can control that, that's also a parameter which you can configure in the config parameters, to be honest. And then, using the kernel, I actually invoke the prompt and also pass the input parameter which I want to summarize, basically. And this is a short text about what semantic kernel is, to be honest. I'm going to run it anyway, but you know what it's going to do. It's just going to summarize it in below 250 words, and it's going to show you the results. It's going through my mobile connection and coming back, so it's a little bit slow. Although I don't have a slide for it, but at the end, I'm going to also tell you what Semantic Kernel cannot do, so that you also know what you cannot achieve with that. And that's also very important when you're choosing an orchestrating framework, to be honest. So yeah, it came back with a summarization using an LLM. Mind that, an LLM. I haven't mentioned in this whole code which LLM I'm actually invoking, where it is sitting, et cetera, et cetera, et cetera. So with that example, I just want to mention that the AI orchestration framework which we talk about sits actually in between. All other infrastructure is below you, all the LLMs, all the VNet, all the storage, all the databases. Top of it is your application which is consuming it. It can be a chatbot, it can be another API, it can be a pipeline which is deciding whether should pass the PR review from Soham or not. But you want to manage these two applications in between with an orchestrator. And one of them is Semantic Kernel, which has 3 SDKs, Python, .NET, and Java. And surprise, surprise, Java is way behind in functionalities from Python and .NET. Sometimes I want to, I'm on record, but still, sometimes I want to think why not also Java, same with .NET, looking at the company which is behind it. But anyway. It's open source. The release 1.0 is, I think, a month old, came out. The previous version was much more bloated. This one is much more leaner and smaller. And I'll tell you the features that it has. So as I was saying, the semantic kernel sits in between. And you can attach different services to it. And those services can connect to an LLM what they want. And here comes the first limitation. Semantic kernel connects with OpenAI, Azure OpenAI, and Hugging Face model. So if you have a local LLM or any other LLM, it doesn't connect to yet. On a Python version, it does, but on Java and .NET, not yet. It also connects to the plugins, they call it in semantic kernel world. The plugin is basically a job that it needs to perform. It can be a summarization, it can be a vector database call, it can be an API call, et cetera, et cetera, et cetera. And the kernel basically orchestrate, depending on the task given to it, whether I should invoke an LLM or should I invoke a plugin. Now that I talked about a bit of a plugin and service, let me show you the code which actually initializes this all. So everything starts with an OpenAI client builder. This is basically the core of where you define which LLM you are connecting. Right now, in this example, I'm connecting, depending on a config parameter, to OpenAI endpoint or an Azure OpenAI endpoint. What it does after that is create a service, which is this. And there goes the OpenAI client inside. And in a kernel, you can add as many as services you want. And depending on which service you want to invoke, it'll connect to the LLM corresponding to it. It also adds plugin. Even though this example has one plugin added, you can add as many as plugin as you want. It's a list in the backend. And these plugins will be actually the task that you want to perform. Again, I'm repeating itself, to be honest. So let's see a plugin which is defined as a prompt. So semantic kernel supports templating language as well, handlebar, but you can also define prompts in plain old English. And the way it defines it is with two files. One is the prompt.txt, which basically tells you what to do with examples or not. And another is config.json, which tells you the parameters that you have to use to invoke the LLM, which gives you the flexibility of using the LLM in a deterministic mode for one task and non-deterministic mode for another task. And the way it invokes it is as a file. It reads as a file, and it adds to the kernel. And same way, I'm invoking the summarizer plugin for a particular input. Pretty much similar to the previous example, but here I'm configuring the config parameters and the invocation within the kernel itself. But what if my plugin is a class? Very stupid example, but still. I have two kernel functions here. One is doing it in uppercase, another is lowercase. But for the sake of example, I chose a very simple one. But think of you are invoking a database service or a vector database service or an external API. You can define that here. And what it does is it defines it in a very type-safe way. So if you have a custom object to return or a custom object to receive, the LLM will help you converting those things in between. I'm going to show you in a bit how you do that. But here, my plugin is not really a text, not really a reading of a file, but rather an object which is added to my kernel. Rest is very much similar. So if I want to run this, I provide the text to summarize. First, I do the uppercase one, and then I do the lowercase one. And then, yeah, I basically have the results back, the summarizer. So it is in the uppercase and in the lowercase. Think of a situation when you have 20, 25 different tasks registered to a kernel. But depending on what you ask, it needs to figure out which task or tasks I need to perform. Or in other words, which plugin or plugins I need to invoke. All those previous examples, actually, I mentioned what to invoke for which variable. But in this example, I'm going to add a bunch of plugins to my kernel. And I'm going to say, OK, do this or do that. And what it'll do is, with the list of plugins, it'll ask the LLM, do you know which all things I can use for this task? And the LLM will tell you, OK, you can use this plugins to perform this task. And it'll invoke that. And that's not a out-of-the-box feature. You need to instruct the kernel for doing an auto-invocation. And that's where this magical line comes in, where you say, my tool call behavior will be automatic. And depending on the task, so I want to rewrite this content in Yoda style of Star Wars, it'll figure out that within my writer skill, I have a rewrite function which will take in style as an input and actual input, and it'll try to rewrite that in that particular style. So in this example, my text to summarize thing is my input, and the style is Yoda from Star Wars. And it'll try to write that. Every time it comes with a different result. So it's actually quite interesting how LLM basically look at problems in a different way than a human do, to be honest. Again, latency is a big thing with GPT. I'm using GPT-4 with 32K tokens here. So yeah, it came back with quite a Yoda. So I'm not a Star Wars fan, but if you are, you might recognize it. Now, if you look closely, most of the LLMs deal quite nicely with if there is a string input and a string output. Because they are largely text-based, even though there are GPTs are multimodal and other LLMs are also multimodal, some of them. But they do deal much better with text. But in a normal real-life applications, you also have custom objects coming in and going out. So one function splits out a custom object, another function receives a custom object, and then it goes into a bit of a trouble because you need to translate that object into some form of string so that LLM understands it. And also, while coming back, you need to transform that string to an object which you can pass into your function as well. So the way to do it in Semantic Kernel is defining a mapper. And the mapper comes with three methods or three function definition. One is if you have an object to object, if you have an object to string, or if you have a string to object. LangChain 4j does that automatically for you to JSON, but this gives you a flexibility if you want to push in XML or any other different format you want. And normally, you should do that with object mapper. So I commented out this part, but normally, ideally, you should do an object mapper from object to JSON or an object mapper to object to XML. And on the way back, also converting object mapper to read value to a class object. And even though it's very much verbose in this case, but you have much more control over how you want to manage these incoming and outgoing values. So if you have a object to string to object to a different object, and you want to do some manipulation before you feed in that object to your function, you can do that here in much more controlled way than any other framework. And I use that in my search plugin, which is a again pretty stupid function, but it takes an input and tries to send back an object, in this case, a person. Am I doing? Oh, no, that's not the one. This one sends back a person. It can also be a normal person entity. It doesn't have to be a reactive object, to be honest. And I'm using this by a chat. So I'm asking it to find a person whose name is Soham. That's me. And it'll go through the conversion of finding the person. When the person is returned, the LLM will receive that as a string and try to reason with that string and give you an answer back that, yeah, I found a person who is 41 years old. And that's what exactly I sent back with an age 41. So what a plugin can do. A plugin can automate your task. It can retrieve data. It can use to send emails. It can complete your sales. It can make your orders. It can do much more, because this is the code you're writing. Basically, your business logic goes in there. And your AI kernel, the semantic kernel, is managing how to invoke which one in which scenario. And what you can also think of, making these plugins online and available as a library to use to your other part of your organization. So you are making AI plugin library so that the rest of the organization can also make use of it as a normal library or a dependency that people use within a normal Java project. And the kernel will orchestrate this every time when a task comes in. So it'll select the AI service that needs to be invoked. It'll render the prompt that it needs to send it to the LLM. And it'll also invoke the functions that are need to be performed in that respect. I'm going to show you a small example of a simple RAG, basically. So I have, if you're familiar with Azure, this is the Azure AI search. It's Azure's vector database, basically. So same as Pinecone or VV8 or any other vector databases. So I have an index of resumes. So I downloaded from an open source data source where I have around hundreds of resumes from anonymized from different sources. And what I did is I indexed it. So I created a vectorized database out of those resumes. And I have a few fields here. The last one is the content vector. And I'm not going to show you the vector representation at all. Because I kind of hate whenever LLM and vector comes together. Because when you're providing a context, it can also be a non-vector. So I'm going to show you a non-vector example here. I'm not going to query a vector column, but a normal Lucene search. So what I did is here, I have a search service. Yeah, I have a search service, which is basically doing a search based on a query on my Azure AI search. And this is using the SDK for Azure AI search. So semantic kernel, second limitation, doesn't give you any connector out of the box. If you are using a vector database or a data source of your own, you bring in your code, your library, your implementation. What you can do is define that within a function or a plugin, which will invoke your code to get that data, basically. So here, basically, I'm doing a search operation, a simple search to get two columns, the content and the title. And what I'm going to do after that is try to fetch the top 10 skills from this resume and list it in 20 words or less. And I also define that I do get the input as a JSON, because I'm converting the search results from my vector database in a JSON format. And I have a small test written, even though that's not a test. But what I'm trying to define here is a system message, which stays constant for the whole interaction with the LLM. And I'm telling it that you are an assistant who helps finding, matching resume. And then I want to find if there are people with SQL Server experience. Why am I showing this to you? Because the LLM, if all goes all right, will extract the query that needs to be performed against the vector database. And then it will query the vectorized database, even though it's not a vector results I'm returning. And then it will use it to give me back the summarization of the top 3 results. So I'm only retrieving top 3. So you can also control how many results you want to retrieve from your knowledge base, to be honest. So if you see, the resume search is on SQL Server. So it'll going to call the SQL Server as a keyword to do the search. And the latency is hitting me again. And it came back with top 3 results, defining the SQL Server or something to do with a database associated with top 3 resumes. You see the fake URL, resume 1, resume 2 in the title, because these all resumes are anonymized. So that's why the top level title is a little bit weird. But this is an example of how you combine a different data source along with a skill that's going to help you to achieve a task. So think of a recruitment agency who is getting thousands of recruitment options every day, and they have a huge database of resumes. And somebody just onboarded to this company, and this person doesn't know most of the people who are in the database. How would you make this person's life a bit easier to search on the perfect top X results of resume if a requirement matches? So everything in Semantic Kernel is a plugin. Doesn't matter what you want to do. It's a plugin. You define it. You use it. It can be a prompt. It can be a function. This abstraction is throughout the whole model. I didn't really talk about the services which are associated with it. And all of my examples, I've used a chat model. There is another service called text completion service, which uses specifically the Da Vinci generation of LLMs, which does only the completion of your texts. But with a chat completion service, you can use GPT or any other OpenAI model, which are transformer models, to be honest. And when you have a task which requires multimodal strengths, so you also want to have video, audio, images to be added, then it's also easier to define the functions dependent on that. So you also have a plugin support to do these as well. So it doesn't really matter the multimodality of the large language model you are using. It all matters how you define your plugin and functions in the kernel, to be honest. So a normal RAG structure in Semantic Kernel would look like that you have a question coming in, Semantic Kernel try to create an embedding with the query the embedding store to get the results back, then enrich with some external APIs which you might have, and then use the LLM again to give you an answer back the way you want to get the answers. So another example could be Funair. This is an application built by Marcus. He's a DevRel from Vaadin. He made this application for LangChain and Spring AI. I added the Semantic Kernel, so I can also demo this. Even though this is a very simple application, what I like about this combines the power of talking to a structured data, because we talk about vectorizing data, knowledge base. These are all based on documents, PDFs, Excel sheet, PowerPoint, et cetera, et cetera, et cetera. But we never talk about really, if you have a tabular data, if you can query those data, how you integrate that into the system, along with some knowledge base. So for example, if I want to cancel something, what is the cancellation policy? And this should trigger the kernel to call a knowledge base to get the policy, rather than the structured data source, which has the data, to be honest. And if everything goes all right, you will also see that it's going to call the search with the cancellation policy. So it takes out the text that needs to be queried on the knowledge base as well. And again, latency is going to kill me. So it comes back with some information, which basically is also defined as the cancellation policies in my fake data store. What I also like is when I want to interact with a structured data, I have specific requirements. So for example, if I want to get a booking details, it needs my first, last name, and also my booking number to get that. But if I just say, I am Williams, can you get my booking details? It understands, hopefully, that that's my last name, and it should ask me for first name and the booking number. To be very honest, when it figures this out, it doesn't have the context of what data sets in my database. And if I now say I am Sarah and 104, yeah, it should basically do the query, using the chat history, which was William, Sarah, and 104, to give me back my details in a bit, slowly. Yeah. San Francisco, yeah, that's good. So now that I've shown you 3 different type of examples, I also want to talk about a bit, 40, I have minutes. I also want to talk about a bit of top use cases with LLM. I mean, I think we all know the content-related use cases, but there are also a lot of use cases which are hidden and unknown for most of us when we are dealing with large language model. For example, what I like, and also right now working with a partner in Netherlands, is call analytics. So if you are running a call center application where you get different type of feedbacks via phone, email, WhatsApp, social media, etc., 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 how would you figure out which product needs which feature improvement, and how would you deal with thousands of different sources of data? So what we're trying to build is an intelligent system which parses these feedbacks properly, segregates in different category, find out what matches the product feature this feedback was posted on, and creates an issue in their internal system and prioritize it as well to work on it on their next product life cycle. And which could take a normal group of people a few months. This is being done every night within half an hour or so. And now that few months of time being invested in a much more smarter and effective way for that team, rather than going through X, Facebook, WhatsApp, Bol.com, Amazon to figure out what I should do with this query. And now you can also tell your friends and family that I work in a very intelligent application rather than reading feedbacks on internet. Another one was as well quite interesting was personalized content generation. So since I work with a lot of startups, they come up with features and they send it to their clients. But the way every country works, they wanted to personalize the product feature the way, or the country that the customer resides in. So they use LLM to actually create the product feature or describe the product feature using LLM for that country itself. This is the simple architecture diagram of what I just showed for the booking application. So you get the booking details, and using a orchestration model, doesn't have to be semantic kernel, but it can be semantic kernel, you figure out what the entities I need, what the function I need to call, and invoke that in as well. Also, if you have a claim process engine which matches the incoming payments to the open claim data, and let's say this month I'm low on cash, I ask my wife to pay it, but the system doesn't recognize that this payment is actually for my claim, how would you match that? Depending on the amount is paid, depending on the policy number it mentioned in the bank transfer, depending on the time it's going to get paid. So it's not a simple matching service. So when you are thinking of such kind of an application, you can also think of using LLM in between, which will help you to figure out if I have an open bank transfer needs to be, open claim needs to be paid, and I have 20 bank transfer came in, which all top 3 or top X basically matches with that open claim. And this is also a real-life application I'm working with a Dutch client, to be honest. The call analytics side of it, it's just talk about the telephony server, but you can also think of any other source of messages that comes in as to analyze. And once you analyze the data and you create a structure out of data, you can think of putting the data anywhere you want. It can go to your Power BI dashboard. It can go to your, create a nice report for your upper management, or even to put it in a CRM where you might need to follow up on a few things. So options are quite open up, and you don't need to create different connectors for different applications that you want to plug in at the end. With that, all three applications that I showed are on my GitHub, so you can go play around. The AI search, I haven't put a README yet, but I'll do that in a bit. But the rest are there. There's a quick start guide for Semantic Kernel. Semantic Kernel, GitHub has a Java sample directory, so you can also check quite a lot of examples there. I have just given you a sample of it. And you can find me in all sorts of medium, and let me know if you have questions. Thank you. Yeah? It's all OpenAI models.
Hello. Yes. Which models are supported beside just GPT-4, GPT-3.5? Are there other LLMs also from other providers?
Yeah.
Thank you.
It is provide. So it supports all GPTs. It supports DaVinci and the generation of DaVinci. So you can also do Babbage as well.
Okay,
it doesn't support embedding, so it doesn't do embedding for you. So if you are vectorizing your data, creating embeddings of your data, Semantic Kernel doesn't have ways to do that. So you have to use the SDK of that particular vector database to do it. Thanks. Any other questions? No? Then thanks a lot.